Hi, Algebra 2. Now we are going to work on 10.6, graphs of other trigonometric functions. We've talked about the sine curve and the cosine curve. Now we're going to talk about the tangent, the cosecant, the secant, and the cotangent. First of all, there are several things we have to consider. A reciprocal function is a function that's been flipped over. So in other words, this 1 over the sine is the cosecant. So if the sine is 0, 1 over 0 is undefined, and that's where you're going to find your asymptotes. So if it asks you where your asymptotes are located, just look on your unit circle and find out where the sines are 0. Where the sine is 0, the cosecant is an asymptote. It's undefined. Where the cosine is 0, the secant is undefined. Where the tangent is 0, the cotangent is undefined, and when the tangent is undefined, in other words, where there's asymptotes, the cotangent is 0. And I'm going to graph the tangent for you to show you what I mean. Okay? So this is the pretty much where you would find your asymptotes. So let's graph tangent of theta. First of all, what is the tangent of 0 degrees? Well, the tangent of 0 degrees is 0. So we would plot it right there. Halfway to 90 degrees is 45 degrees, which is pi over 4. Well, the tangent of pi over 4, if you look on your unit circle, is 1. The tangent of negative pi over 4 is negative 1. Now look at the tangent of pi, the tangent of 90 degrees. You will see that it's undefined. So if it's undefined, you put an asymptote. Same for negative pi over 2. So if you were to graph this, it would look something like this. Now, since it is a periodic function, if you continue it, it will keep repeating, doing that. Now notice one interesting thing about tangent, and the same thing will go for cotangent. It repeats after pi degrees. See, negative pi over 2 to pi over 2 is a period of pi. So the period of tangent and cotangent is just pi, not pi over 2 like all the other ones. But it is still a periodic function. It is not continuous because it has asymptotes. If it has asymptotes, it cannot be continuous because it has to break up. It cannot exist at an asymptote. So this is what a tangent is. Now, if I was to draw the cotangent, y equals cotangent of x, then everywhere there's an asymptote would now be a 0. Everywhere where there's a 0 would now be an asymptote. 0, asymptote. So see, it would shift it over. And then, because the 0 is here, and the cotangent would still be 1 here, it's going to basically shift around the other way. So it's going to, see, I should not draw it on top of the other one, but it is going to go this way instead, because the cotangent of pi over 4 is still 1, because the reciprocal of 1 is 1. So it's going to shift this way because the asymptote is now there. So your cotangent, which is in the blue, is going to go that way, and it's going to be shifted over because anywhere the tangent is 0, the cotangent has an asymptote. So that's what the tangent looks like. And remember, the period is just pi for those. Now let's take a look at the secant and cosecant. First of all, whenever you want to sketch a graph of those, first sketch the graph of its cofunction. So the secant is the flip of the cosine. So the secant of x equals 1 over the cosine of x. So first of all, the amplitude is the absolute value of -3, so the amplitude is 3. it's negative, so negative means it's going to valley at 0. It's got a period of 2 pi because there's no number in front of there except 1. And there's no shifts or no up or down or left or right shifts. So we're going to sketch it by making a few curves. We're going to go through there and through here. Now the amplitude is 3, so that means we mark -3 there, okay? And the period is just 2 pi, so this will be 2 pi. Halfway would just be pi, okay? And then half of that is pi over 2, so this would be 3 pi over 2. Now, we want to graph the secant, which is the flip of the cosine. So we've basically drawn, actually, I'm sorry, I drew this wrong. This, I'm going to draw the whole thing again. It's negative, so it valleys at 0. So I'm going to make this 0 and this 2 pi. So this is pi, and this is pi over 2, and this is 3 pi over 2. I hope I haven't confused you too much, but you've got to watch out. If there's a negative in front, that means it's a valley at 0, not a peak at 0. So I started it over here, but that's okay. Now I've fixed it, just put the right numbers under there. So from a valley to a valley is 1 period, which is 2 pi. The amplitude is still the same, doesn't matter. So now, this is the negative cosine. So I have just drawn y equals -3 cosine of x. But now I want to draw this. So if I look over here, wherever the cosine is 0, the secant is undefined. Because if the cosine is 0, it now becomes 1 over 0, which is undefined. So draw an asymptote anywhere where the cosine is 0. You see that? Every place where the cosine is 0, you draw an asymptote. Then the amplitude is going to stay the same, but you just draw these little parabolas starting at the little peaks and valleys. So basically, once you've drawn your cosine or sine curve related to your secant or cosecant curve, all you have to do is dot in your asymptotes and draw your parabolas going up and down. Another way you can do these is you can easily graph these on your graphing calculator. Make sure your make sure your zoom is on trig, which is zoom 7. And you can graph, go to the y equals, and secant is 1 over the cosine. So you would type in -3 parentheses 1 divided by cosine x. Close the x parenthesis, then close the other parenthesis, and graph. And you'll see it'll come up looking similar to this. You can also graph the tangent and see what it looks like. You can graph the cotangent, you can graph the negative tangent. So whenever you get homework problems like 5 through 10, where you have to match the functions to the graph, and 19 through 24, just punch in the formula and into the y equals, and then look at the graphs and match them up. Don't forget, when you punch it in, you have to punch 1 over the sine for cosecant in parentheses, 1 over the cosine for the secant, and 1 over the tangent for the cotangent, and make sure that's in parentheses. 1 divided by tangent x, close that parentheses, close the other parentheses. Make sure you punch it in that way. There might be another way to punch it in there, but you've got to remember you're talking to me, who is not very technologically advanced.